What I've done now is build a topology locally so that we can look at the router configurations. I've got both a client router up here as well as a server router over here, which are connected to an ISP router. I've got a client, so our client as we had before, but what I've done now is introduce another Windows computer into the topology that's going to act like our server. This will allow me to show you overloading, so how to overload NAT, where we get multiple devices to use the same IP address on a router, as well as static NAT. So we'll configure static NAT on this router so that we can access the server. I'll also be able to show you dynamic NAT in this topology. So I'm going to show you multiple options when running NAT on this client router as well as this server router. Okay, that's enough talking. Let me show you the configuration. Okay, so on the client, just to show you what's happening in the topology, I can open up a web browser and browse to 45.56.73.104. So in other words, I can connect to this IIS server. That IIS server is running on the laptop at the top there. So notice here I've got a little web server. I stop that web server. If I go back to the client, notice now the client can't reach that server. So this laptop is unable to reach the IIS server on that laptop. But again, if I start the service again, so I'll start it here and go back to the client computer and refresh, I can access that server. So again, on the server, I'll stop the service, go to the client, refresh the page, and that will no longer work. On the server, start it, and I'm able to access the server on the client. But that's only made possible because in this topology, I'm running NAT on this client router, and I've also enabled NAT in this example on the server router. Let's start with the client, and then I'll show you how I've configured the server. So as an example, this server's IP address is actually 172.16.104, and I'll show you how I enabled static NAT to allow the client to access that server through the internet. Okay, so the client can currently access the server, but that's only because I've enabled NAT on the client router over here. So in this example, the client is connected to the switch, which in turn is connected to the client router. If I disconnect that connection on the router, it goes down. If I type show IP interface brief, notice interface is now down. On the client, if I type IP config, IP address is this. If I try and ping the router, the pings don't succeed. If I connect the router back, hopefully pings will start succeeding. As you can see here, the interface has come up on the router. So show IP interface brief, interface is up, but we need to wait for spanning tree on the switch. So as soon as spanning tree is converged, I'll hopefully be able to ping the router. And there you go, I'm able to ping the router. Now, what I'm doing here is a lot harder than just using a simulation. But again, I think it's really important that you see how things actually work. While I was building this lab, I actually ran into a bug on one of the Cisco routers, caused me a whole bunch of issues. But this is more real world rather than just using a simulation. I'm showing you practically how things actually work. Hopefully, it helps you learn better. But at the moment, I can ping the router, and back in my browser, I should be able to connect to the web server, which I can. Okay, so that's fine. But let's have a look at the configuration of these interfaces. This interface gigabit 001 is the inside interface. This interface gigabit 000 is the outside interface. So show run interface gigabit 001. Notice interface is configured as the inside interface from a NAT point of view. Gigabit 000 is the outside interface. So when you configure NAT, and this is actually what is called port address translation or PAT, we need to specify inside and outside interface, and then we specify the interface that we're going to overload. We are basically allowing many devices to use a single IP address. This is very similar to what you have at home, where you have a PC or a phone or another device sharing the IP address of your router. So I've decided to show you this one first, a little bit more complicated, but hopefully will help you understand. We're going to configure NAT as follows. We're going to, in global configuration, use the command ipnat inside. We want a NAT inside host IP addresses, and we're going to NAT source IP addresses rather than destination IP addresses. We're going to point the NAT to an access list, in this case, access list 1, which permits all traffic to be NATed. You may decide to only NAT certain IP addresses, but in this example, we're going to permit all IP addresses to be NATed. The interface that we're going to NAT to is gigabit 0/0/0, so that should be a 0 because that is our outside interface, and we're going to overload it, which basically means we can have many devices be NATed at the same time. If you don't use the overload command, only one device will be NATed, and that's obviously not a good idea. We want to enable overloading to allow many devices internally to be NATed to our outside interface. In other words, our router interface. So again, we're going to NAT multiple devices per this access list to gigabit 0/0/0 because that's our outside interface. And overloading allows us to NAT many IP addresses to the outside interface IP address. So rather than doing a one-to-one NAT, we are going to take many devices and NAT them to the IP address on this interface. Okay, so if I use the command show run pipe include to show us all commands with the NAT keyword, we can see that we've got IPNAT outside, IPNAT inside configured. Those are the commands on our interfaces. And then I've added this command, IPNAT inside source list 1 interface gigabit 0/0/0 overload. Show access lists. You can see I've got one access list 1, permitting anything. If I type show run pipe include access list again, you can see that access list there. Okay, but what I'm going to do now is remove NAT. So I'm going to say no IP NAT outside on this interface. I'll remove NAT from the inside interface, and I'll do all the steps with you once again, showing you what's happening. Just going to clear the IP NAT translations because it won't allow me to do that while there's translations. And then I'm going to say no access list 1. Okay, so show run pipe include NAT. All I've done is removed all the NAT configuration from the router. Notice now this no longer works because the inside host is no longer able to access the internet. IP config here, this device, my local PC, cannot access the internet because we have disabled NAT, or in this case, PAT. Notice there, site is no longer reachable. NAT in its purest form is a one-to-one mapping. PAT is many devices to one IP address using ports to differentiate between the devices. Okay, so let's start from the beginning. Let's assume brand new router. All I've got configured on the interfaces are IP addresses, routing, but there is no NAT configured on this router. The client PC, once again, is not able to access the internet. So first thing we're going to do is type IP NAT. What are we going to NAT? Are we going to NAT inside devices or outside devices? Remember, devices on the inside are internal to our organization. So we're going to NAT an insider or internal device on our network. What are we going to NAT? Source addresses or destination addresses? We want to NAT the source address. So traffic sent from this device going onto the internet will be NATed. What are we going to NAT? Which devices can be NATed? I'm going to specify a list. This is an access list. So you can use a standard access list or extended access list, but I'm going to use a standard access list here. What are we going to NAT those devices to? We could NAT them to an interface or pool. I'm going to NAT the devices to an interface. So the interface is going to be gigabit 0/0/0. And don't forget to use the word overload if you want to NAT many devices to a single IP address. And I'm going to show you in a moment how that's different to what I showed you previously with NAT. This basically enables PAT or port address translation. Access list that we need to reference is access list 1, and I'm going to permit any traffic to be NATed. So all we've done at the moment is configure this single NAT command. I've also created an access list, so access list 1 permitting anything. The device can still not get to the internet server because we haven't told the router what's inside and outside. So on our router again, inside interface is this interface. Notice the RFC 1918 address. This interface is our outside interface. So conf t interface gigabit 0/0/1 IP NAT, and we can decide if this is inside or outside. It's going to be our inside interface. I'm going to jump straight to the other interface, so gigabit 0/0/0 in this example, and I'm going to simply type IP NAT outside. So show run interface gigabit 0/0/0. That is our outside interface. Gigabit 0/0/1. That's our inside interface. Show run pipe include NAT. That's our command overloading the outside interface. Show IP NAT translations. You'll see immediately here I have some NAT translations. This is real world. Windows is going to send traffic. It's already trying to send traffic to a DNS server. So that server, it's also sending traffic to our web server. So immediately here you can see that the page is refreshed. We can access the web server because Windows just tries to send traffic immediately. We didn't have to manually initiate traffic. But what I want to show you here, because this can get really confusing, is inside local. This is the IP address of our PC, 192.168.1.12. So here on our PC, IP address is 192.168.1.12. So that's our inside or local IP address. It's been NATed to this IP address, 145.224.65.100, because that, if I scroll up here, is the IP address of our outside interface. The PC is being NATed to the same IP address as the router. The server that the traffic is going to is 45.56.73.104, port 80. Notice inside local and outside global look exactly the same because we are not NATing the server's IP address as I previously explained. Now, these are port numbers. The reason why we have port numbers is because we want to differentiate between different sessions. We can NAT multiple devices to a single IP address, so we need to differentiate the sessions, and the way we do that is using port numbers. So notice the host chose this port number as its source port number when sending traffic to the server, but the router changed that to this port number. So when traffic arrives back from the server going to this IP address and this port number, the traffic is sent to the client with this port number. On the client, let's open up another browser. So I'll just make sure I've got multiple browsers here, all going to the same IP address. So I've got Chrome, Brave, and Microsoft Edge all going to that server. So show IP NAT translations. You'll notice we have a lot of entries here. Here are 3 entries to the same server. The client has chosen different port numbers for the sessions. So each browser is using a separate port number, and the router is differentiating between those sessions by these port numbers over here. The problem here is when traffic goes to the server, how does the client know which traffic belongs to which session? It's based on the port number. So unlike previously where I explained that inside local gets translated to an inside global address and just looks like this, what we're actually doing is adding port numbers because we could have multiple PCs here all sharing the same IP address. And the way the router can differentiate between different devices on the traffic coming back, so if these 2 devices were sending traffic to the server, or multiple sessions on a single server, is to use port numbers. So what I'll do now to hopefully make this clear is explain a little bit about dynamic NAT, and then I'll explain PAT or port address translation again. The reason I started with port address translation is that's what most of you know, where you are NATing multiple devices internally to a single IP address of your router at home. But let's assume here we've got 2 PCs, 10.1.1 and 10.1.1.2. They are going to be NATed by this router. The router has this IP address, but notice PC1 is going to be NATed to 1.1.1.2, and PC2 is going to be NATed to 1.1.1.3. So each device here has its own IP address. This is not going to help us conserve IP addresses. Each internal host or private host has a public IP address associated with it. This is classic NAT. So notice the inside local IP address is NATed to an individual inside global address when connecting to the same server. So when traffic is sent, say, by this PC to the server, the source address here is going to be 10.1.1.1. But if we capture the traffic here, the source address is going to be 1.1.1.2 for PC1. When we capture the traffic on this link for PC2, the source address is going to be 1.1.1.3. This server is going to believe that it's talking to 1.1.2 for PC1, and traffic will be returned to that address, and this IP address will be translated back to that, as we can see in this table. For PC2 session, When the server replies, it's replying back to 1.1.1.3, and that IP address is translated to this IP address. So the router is able to differentiate between different sessions because different IP addresses are used for each individual device. That doesn't apply with PAT or overloading or port address translation. With overloading, we have our two PCs with IP address 10.1.1 and 10.1.1.2, but they are NATed to a single IP address. So in the previous example, we had 3 IP addresses, one for the router and one for each host. Here we have only one IP address, which is the router's IP address, and we're going to NAT multiple devices to that single router IP address. So to allow for individual translations, the host's IP address of 10.1.1.1 is NATed or PATed in this case to quadruple 1, but the port number information is also kept. So if two hosts, this PC and this PC, choose the same source port number, the router will change the port numbers to make sure that the entries are unique. The outside local, outside global looks the same. Notice we have port 80 for both of these entries, but the idea is when traffic comes back from this PC, how does the router differentiate between the sessions? If traffic is going to this IP address and this port number, it goes to PC1. For this session, when the traffic comes back, if it's going to the same IP address but this port number, it's translated to this IP address on the local network, so the traffic goes to PC2. So back at our physical example here, we've got one host, 192.168.1.12, but it has multiple sessions to the server. Notice these two TCP sessions here and this TCP session here, all going to the server. The router is able to differentiate the sessions by allocating unique port numbers to those sessions. So when the traffic hits the PC, it knows that this traffic is for a specific session, this traffic is for a different session, and this is for the third session. Those translations have timed out now, so let's initiate it again. So this is the Edge browser. I'll refresh the page, show IP NAT translation. We can see that session there. So that's our Edge session. I'll refresh it in Chrome. Here's our Chrome session. Notice 5063 is the port number used there, which is different to the previous example. And I'll open it now in Brave. Third browser, show IP NAT translations. We have 5064 now, so different translation used by the router. These sessions are a single device, but different browsers. But probably what's going to make more sense is if we connect another device to the network. And to make this more interesting and more real world, what I'll do here is use a phone. So what I'll do here is connect an Ethernet adapter to the phone and then connect that to the switch. That's connected directly to the switch now. So my phone now is connected to the switch. So what I'll do now is open up a browser and I'll go to 45.56.73.104. As you can see there, I have now got my IIS server running on my phone. And if I look at my translations, what we should see is that there is a different device. What you'll notice here is a lot of traffic is sent into the network by the phone. So what I'll do actually is just include 45.56.73.104 so that we only see those sessions. And what we can see here is a device with IP address 192.168.1.13 has opened a session to that server. So the PC's IP address again is 12. If I refresh the browser on the PC and look at my NAT translations there, you can see we've got the PC connecting to the server, 192.168.1.12, and we've got the phone, 192.168.1.13, also connecting to the server. They are using their own ephemeral port numbers or random port numbers, but the router is changing those port numbers to these port numbers, and the router's IP address is used throughout. So the router needs these port numbers to differentiate between the sessions from different devices going to the same server. Because if traffic comes from the server, so this IP address and port number going to this IP address, how does the router know if the traffic belongs to the PC or the phone? It's because of the port numbers here. Those two, the combination of IP address and port number, gives us a unique entry in the NAT table. So that combination means that the traffic goes to this device and this port number. That combination means the traffic goes to the phone using IP address 192.168.1.13 and that port number. So again, on the client PC, if I open up another session again, I'll open up a few here on the different browsers, and we have a look at our translations again. Okay, I need to filter that. What you'll notice is we can see those 3 sessions. I will refresh it on the phone now and run that again. There are our 3 sessions on the PC and our session on the phone. Remember the combination of IP address and port number, what Cisco call PAT, but commonly referred to as NAT, gives us the device that the router needs to translate the traffic to. So the router knows that that IP address and port number goes to that phone device and that port number. In other words, going to the browser on the phone as shown here. Now, I've shown you translations. They are all our translations. The phone sends a huge amount of traffic. Lots of DNS entries sent to 53. You can see traffic going to HTTPS. Phone is sending plenty of traffic into the network. So I'll disconnect the phone here because it's sending a lot of traffic. And those entries will time out. But what I'll do is clear the IP NAT translations. But before I do that, actually, what I'll do is just have a look at statistics. So show IP NAT, and let's look at statistics. We can see the number of hits and misses and expired translations in our NAT table. So notice many hits. The phone sends a lot of traffic. Total active translations at the moment is 26. So if we look at our translations again, that's being updated. The phone is no longer there. But as soon as I plug the phone in, it's going to send a lot of traffic into the network. So we should see that update now. So now it's back again. So if we look at the translations, you can see many translations there. In statistics now, we can see many hits. Okay, that's real world with a phone and a Windows computer. I've now shown you how to run PAT or port address translation. Show run pipe include NAT shows us the configuration. We are overloading the outside interface on the router. Basically, many devices are sharing the IP address of the router. This is what your router at home is doing. So if you're not using a Cisco router, let's say using a firewall or some other kind of router, they are essentially doing this. They are taking multiple internal devices and patting them or port address translating them to a single IP address on the outside interface of the router. In other words, the internet-facing interface. So again, show run interface gigabit 000. This is our outside interface. In other words, the interface facing the internet. Show run interface gigabit 001. This is our inside interface or the internal interface of our network.